Hello and welcome back to my channel. Students, as you all know, in this problem series we have already completed 15 problems and now it is turn of problem number 16. We have been doing general organic chemistry, all these problems, and in this topic we have already taken up some of very important topics like aromaticity, carbocations, carbene ions, acidity, basicity, etc. You can watch my videos for the 15 problems. Now let us try to see what is there in our problem number 16. In problem number 16, as you all can see, the structure of compound is given, and this is a carboxylic acid, and we have two carboxylic group attached with two different benzene rings, as you all can see on your screen. We have two hydrogens mentioned as A and B. You have to tell which is a stronger acid, which is a weaker acid. So I have already told you the way you have to perform this type of question. Like you have to take the hydrogens out one by one. As you take the hydrogen out as H plus, you will get an anion. The resulting species will be an anion, the conjugate base. For that anion, you have to see whether it is stable or not. You have to see for the possibility of delocalization of negative charge. If there is fair enough possibility of delocalization, the minus charge is stabilized, then that anion will be stable and that particular hydrogen from where it got will be more acidic in nature. So that is how we are going to plan our action. So first of all, before we have proceeded to start taking out the hydrogens, I want to emphasize a very important concept. Now, I have drawn a few resonating structures on this slide, as you all can see. Now, if you find that what I have done, I have elaborated this particular structure of COOH and got your attention on a very important thing. You can see what is that. That is, there is a conjugation of this C double bond O with the double bond of the benzene ring, and because of that conjugation, this COOH group can take up electrons from the benzene ring through its minus M effect, and as it can operate its minus M effect, let us try to see what resonating structures you are going to get. Now, in order to draw the resonating structures, let us try to see double, single, double. So you have to, and you can see this position there is oxygen, this position there is carbon, and I have already told you whenever you see such type of conjugation, double, single, double, there is a possibility of resonance, and in making of that resonating structure, those resonating structures, you have to keep in your mind that you have to shift electrons towards the more powerful, more electronegative element, and in our present case it is none other than oxygen. So you have to shift the pi electrons towards oxygen like this, and simultaneously these pi electrons are going to shift like this. So in the next structure you will get a new pi bond like this. Since the pi electrons from the older pi bond is now shifting on oxygen, so oxygen will get a negative charge, and this carbon from where the electrons have gone away, it will get a positive formal charge. You have got this structure. As you have got this plus structure, again you will find that more possibility is there for resonance. So you can do the resonating structures like plus, single, double. For this to happen, this pi bond will shift like this, and you will now get a plus charge like this. Okay. Again, there is a possibility, and you can keep on drawing the structure. Plus, single, double, you can keep on drawing those structures. But my focus is, as this plus charge comes on this carbon, you understand, there is again a possibility of resonance, that this plus charge can go towards the ring attached with this ring, the next ring to this present ring. What is that? Plus, single, double. So once you see this, then you find that this plus charge is in conjugation with this lower ring as well, plus, single, double. So for that conjugation, for that resonance to happen, you have to shift these pi electron like this, and once you do that, you will get the structure this. From here I have drawn the structure this, and you can see as it goes like this, you will get a new pi bond here as you have got, and this carbon from where the electrons gone away gets a positive charge. And now again you will realize that this plus charge is in conjugation plus, single, double. Then plus will come here, then you will see plus, single, double, and in the lower ring also there will be a delocalization of positive charge, which I have shown in a figure like this. Here I have tried to show you as the plus charge goes in the below ring, it will delocalize amongst these 5 carbon. So the plus charge can be injected into the lower ring through the resonance, and it will now delocalize in the lower ring as I have shown in the figure. Now why I am showing this? Because to let you know a very important aspect of this resonance, what that aspect is. Let us try to see in a fresh slide. Now you can see that in the previous slide we have got till this structure, we have got this structure where the plus charge came inside the lower ring, and you got this structure. Now what I am trying to project is, if you take out this hydrogen number B, it is hydrogen number B. If you take out this hydrogen number B, the minus charge comes on this oxygen and a carboxylate ion forms. And as I have already mentioned, in order to assess the acidity of hydrogen number B, you have to take that out in the form of H+. You have to make an anion, the carboxylate ion, as I have already made in this figure, and then you have to see the stability of this anion. You have to do something so that this minus charge can be dispersed. There is a delocalization of this negative charge, because accumulation of charge is a harmful thing. It destabilizes the species. So if from the previous discussion, if you remember, we had got this particular scenario where I have revealed that the plus charge will percolate into the below the lower ring, and as you can now see, since plus charge is in the vicinity, is in the neighborhood, it will try to pull the minus charge from the COO minus, because plus charge has got affinity, likeliness, love for negative charge. So the plus charge which you see in the lower ring will pull this negative charge from the carboxylate group, and therefore will help in delocalizing this negative charge, and therefore the stability of the conjugate base, this anion, will increase, and therefore it will result in higher acidity of hydrogen number B. Now if I try the same thing with what will happen in the case of hydrogen number A, then we have to draw different resonating structures. Now in the next slide I have tried to draw those structures. Now what I have done, I have elaborated the below carboxylic group and tried the same minus M effect from the below carboxylic group. For that you can see, again you see a conjugation, double, single, double. So what will happen? This pi bond will shift towards more electronegative oxygen, and simultaneously these pi electron will shift on this oxygen. Once you do that, you will see that this particular carbon will get a plus charge, as you can see in your next resonating structure, and this oxygen is going to get a minus charge, and a new pi bond has been created. Now you can see plus charge can again be in conjugation, plus, single, double. So once you do that, you have to shift these pi electron like this, and plus will come on this carbon. Once you do that, I have drawn this structure. You can immediately see that plus will come here. Again you can keep on drawing the structure, plus, single, double. So this double will go like this, and plus will come here. So in drawing all these structures, Because of the minus M effect of the lower carboxylic group, we have seen that a very important difference is coming in comparison to the previous discussion. What that difference is? The difference is the plus charge is not coming at this carbon. Had it came on this carbon, that plus charge would have gone in the conjugation with the upper ring, and it would have percolated from the lower ring into the upper ring. But it has not happened. The plus could not come at this position, and if it fails to do so, there is no possibility of this plus charge can go from the lower ring to above ring. So you will at the end of day will see that because of the minus M effect of the lower carboxylic group, the plus charge is created, but it remains localized in the lower ring only. It could not percolate the upper ring through the mesomeric effect. And now, taking this into account, if I try to see what is the role of the minus M effect of lower carboxylic group on the acidity of the hydrogen number A, I will again take that hydrogen out, the hydrogen number A, make the anion, and will try to see the situation. And the situation is in front of you in this fresh slide. You now can see that in the case left hand side case, I have removed the hydrogen number A and a carboxylate forms. This is a seat of negative charge, a location where negative charge is there, and you should take care of this negative charge by pulling it, by delocalizing it. However, because of the minus M of the carboxylic group of the lower ring, the plus charge could not come to this upper ring, and any withdrawal of negative charge which can happen will happen through this plus charge, which is far from this. As you can see, the distance is more. So the inductive effect, minus I effect of this plus charge that will percolate through these sigma bonds will not be that strong because of the distance issues. The plus charge is far from minus charge. It won't be that able to pull the minus charge and therefore stabilize the conjugate base. On the other hand, I have already elaborated that had this hydrogen been the B1, this carboxylate ion, which is the result, is better stabilized because of the minus M effect of the upper carboxylic group. The plus charge could percolate inside the lower ring, and then you can see the plus comes much nearer to this carboxylate group, and could attract these minus charge significantly to distribute the minus charge in a better way. So more you distribute the minus charge, delocalize the minus charge in a better way, higher will be the stability of that conjugate base, and the hydrogen associated with that carboxylate will be more acidic in the nature. So from all these discussions, we have come to a very important conclusion that the hydrogen B is more acidic in comparison to hydrogen A, and that is how you have to see the question in a very critical manner, taking these fundamentals into account. I hope you all must have got the points I wanted to make through this question. Thank you very much.